Hello guys, welcome back. My name is Arpit Shah and today I'm going to talk about interfaces in Java. So let's talk about some prerequisites first. I'm going to talk about some Java concepts throughout this tutorial. And if you understand those concepts, then this tutorial will be easy for you to understand. And those concepts are constants in Java, classes and objects, inheritance in Java, which basically means how to use keyword extends, abstract classes and methods. If you don't know about these concepts, then you can refer to my other videos. Let's get started. Let's talk about theory first. What is an interface? So interface is just another reference type like a class. Interface is a contract that is binding. So what do I mean by that? So interface is a contract that any class choose to follow, then they must fulfill that terms and condition written in contract. I know it sounds very theoretical, but once I will give you an example, it will all make sense. So bear with me for a few minutes. So as I told you before, interfaces are just like a contract. And if any class choose to apply that contract, then they must meet or fulfill the requirements written down in the contract, otherwise compiler would not let them compile. But if I keep talking about this theory, then you won't be able to imagine how interfaces are actually used or applied. So rather, let's take a real life scenario and then I will take you through how interfaces are actually used. Let's say in this scenario, you are the owner of a big car company and you have few brands which are selling really well in the market. For an example, I have taken here Ford and Toyota. And you would like to know which model performs better than the other. So for that reason, you would write a test class, which I'm going to call car performance test class. And you would write a test case which would give you a comparative test data for each of those models. So let's see how that class would be written. So I'm going to create object for each of those car. So let's create a Ford model, call it Ford. And let's also create object for Toyota model and call it Toyota. Because you want comparative data, you would like to perform similar test cases on both of these cars. So let's say before we even start the test, we would like to print a brand name. So I'm going to call a method brand name. And then you would like to, let's say, run this car at maybe 100 km/h speed. And maybe you would like to check the brake performance. So you can say brake the car when car is at let's say 50 km/h speed. And because we would like to have comparative results, we would like to repeat the exact same test on the Toyota model. So just change the model object to Toyota and we expect them to be giving you now comparative results. So finally we have our test class, and now we have to ask developers of the Ford and Toyota classes to write methods which allow us to run these test cases. So let us assume that Ford developer is sitting in maybe United States, where Toyota developer is sitting in maybe India. So we have to somehow communicate to them that this is our requirement and we need those three methods exactly like that with the similar input type and everything. So how do we do that? So we have few options here. We can either email them our code or we can send them a spec list and they can try and write the class similarly. Or we can call them and try and communicate verbally that this is exactly what's our requirement, this is our method name, this is our input type, and this is expected output type and all that. Now all of these methods, if you think about it, they are all error prone. The reason is because they are either copy pasting some code or copy pasting the name. They can do the typo if they try and type print brand name, and they can maybe change one character to small letter or capital letter. They can change input type, maybe integer to double if communication didn't go smoothly. They might change the return type. So they can do so many mistakes, and currently our example is such a simple example. There is still possibility of mistake. So imagine a complex code where you have to align many developers to implement methods exactly the same way. It will be nightmare. So how do we get around this problem? So this is where the interfaces can come very handy. Remember my statement about interfaces are just a contract. So if we somehow bind those developer to follow certain contract which would not allow them to compile their classes unless they follow our rules and regulations exactly like how we have defined it. So let me show you how that contract can be created, which means interface. So if you remember, whenever you would like to create a class, you right click, go to new and choose class. But in this case, you choose interface because we would like to create a new interface. As I said, interface is just another reference type like a class. It kind of follows the same rules which applies to classes. So the naming convention wise, interface also starts with the capital name. So I'm going to call my interface drivable. Now the another trend that is suggested to be followed is adding this able keyword at the end of your interface names. So example, drivable, runnable, serializable, and so on. And these will make it easy for user to recognize that this is an interface of some kind. You want your interface to be public, so I'm just going to click finish, and you can see that now IDE has created interface for us. Now what separates them from classes, though, as you can see, the class has these keyword class after public, and interface has keyword interface. So this is the obvious way to recognize that this is an interface. Now what are the other differences? So interface is an contract which forces class to follow certain rules. So some of the content interface could have is method signature. It could have constants, it could have default method, it could have static method, and it could have other nested loops. So I'll show you all of these with an example, but let's talk about the general methods for now. So our requirement here is all the developer must be able to write these three methods exactly the way we like it. So what I'm going to do, I'm going to copy these three methods, and I'm going to create a signature here. So because interface can only have method signature, you can't have all the decorations around it. So I'm just going to call it public void and method name. Here it will be public void, and because we would like integer as an argument, we would call it integer speed. And same goes with a braking car, so we want it public void and integer speed. If it is going to return some data, you can change this void to, let's say, returning integer value or timestamp or something, right? Now just to keep example simple, I'm just going to keep it all void for now. So this is our contract. So we are saying whoever would like to implement this interface, they must give me three methods with same exact arguments, and they must implement those methods. So interface just declares the method signature, but it also enforces class to provide an implementation for those methods. So let me show you how that works. So let's say for developer receives this interface, and all he has to do to accept the contract is type keyword implements and then call this interface. Obviously that interface has to be placed in the scope where he can access it, and as soon as he applies this interface, you would see that the compiler says, hey, I can't let you compile unless you fulfill all the contractual requirement. So here IDE is trying to help me. It is saying, hey, there are a few unimplemented methods, would you like to implement it? So I'm going to click on add unimplemented method, and IDE will create these empty skeleton for me. So basically I don't have to do any hard work, I just have to now start implementing those methods. Now advantage of doing this is because now I can't do typo, I can't modify the input arguments or any return types because interface has already enforced all those rules upon me. So all I have to do is just write an implementation. So that way I have no leeway of any kind of mistakes. So let's implement some methods. So brand name, because it's a Ford class, I'm just going to print Ford, and I'm just going to print out each of the method calls so we know that this is the method which is being called. And here it will be break car. So let's try and do the same with Toyota developer. Now Toyota developer also receives this drivable interface. He also calls implements drivable, and he would also be forced to implement this contract. So let's see, then he would also be obliged to provide implementation for all these three methods. Now for Toyota, it will obviously not print out Ford, so I'm just going to print Toyota instead. And same way I'm going to print out the run method and break car method. So once the Ford and Toyota developer implements all those methods, they can provide us both of those classes. We can put them in our project scope, so it will look like something like that. And if we go back to our car performance classes, which used to have all these errors, as soon as I save all those implementation, you will see that all error goes away. And if I execute this code now, it will run happily as expected. So this is the power of interface. Even you are being too far, you can enforce the contract on your developers, and then they would not do some silly mistakes that would end up having to go backwards and forwards between developer and the testers and all that. So this is just a simple example of how interface works. Now interface can do a lot more than just implement simple method. So let me take you through some of the variants of interfaces. As I previously explained, interface could have more than just a method signatures. It could also have constants, it could have default method or static methods and so on. So let's go through all of those ingredients. Let's talk about constant first. What is a constant? Constant is an object that once the value assigned to that object, you cannot change it. So you can declare constant by either making that variable static and assign a final modifier. So let me show you how that works. So if I have a constant named pi and it is an integer type, let me assign some value. Then to make these a constant, you have to say it's a static and final. Now interface do allow you to store constant in the contractual agreement. Now what is interesting about interface is that even if you don't explicitly say these keywords, it will still assume that this pi variable is public static final. So sometime you can just be quick and not be explicit about those three keywords, but interface will still give you the same behavior. Just for your clarity purpose, I would suggest to always explicitly say that so people know they are constants. So that's all about constant in interfaces. Now let's talk about method default. So what is a default method and why it is used in the first place? So let me extend our previous example and then I can explain to you how it works. So in our car performance class, we originally wanted three methods to be implemented the exact same way, and that's why we created an interface called drivable, and then whoever implemented that interface, they had to abide by these contractual agreement where they have to implement those three methods. Now Ford and Toyota developer finished developing their implementation, so everything currently looks happy. But let's say after their implementation, we realize that we actually need a fourth method because we wanted to extend our test cases. So we created a new method signature and called it turn headlight on. But as soon as you apply that, you would notice that all the developers code is now broken, because according to contractual agreement, now they must implement one more method before their code can compile. In practical world, this is not a nice situation because developers going to hate you forever. After they finish their work, now you are forcing them to change their code again. So what is the solution? So solution is that instead of breaking their code, we can implement a default method implementation. So the way it is done is you add default keyword in front of the method, and then you must provide the default implementation in the curly braces. So I'm going to call it let's say headlight on. Let's fix the method name, so it's a turn headlight on method. So what is the advantage of these default method? Because now we have default implementation within the interface, if I save these, you will see that the Ford and Toyota classes are not complaining anymore, because what we are telling compiler that if they don't implement these new method, then use our default implementation. So if they choose to not implement those method, these code will be exercised. If they eventually get time and they want to change this method, they can always override this method by using the override attribute. So let's see how the code is gonna work. So if they, let's say, choose not to implement that method straight away, they can still call this turn headlight on method, and same with the Toyota object. And if we exercise it, it will exercise the default implementation, so it prints headlight on both cases. So since Java 8 implementation, default methods are supported, and for the same reason that if someone wants to extend their interface, they don't have to create a new interface and use it as a parent interface and so on, and people can now provide default implementation within their interfaces and not break someone's previously written code. Now let's talk about static methods. So static methods are very simple. You create a public static void, let's say do something, and you can provide implementation here, which then you can just call this method from your test class whenever you want it. And let's say we print hi. So static methods are just like any other static method from the class, so there is nothing much to talk about that. Now let's talk about extending interfaces. So if you guys remember inheritance concept in Java, which is basically mean the use of keyword extends, then I'm going to talk about just that in an interface scope. You can refer to one of my videos about inheritance if you don't know. So let's get started. So in interface concept, basically if you have a child class which would like to inherit some method from the parent class, you can use keyword extends and then put your parent class name here. So what I have done here, I have created two other interfaces which I can use them as a parent interface. So I can just extend them by just calling the name drivable1 and drivable2. Now one of the rule of inheritance is when you are extending a parent class, you can only maximum extend one parent class. But when it comes to interfaces, you are allowed to extend more than one interfaces. So in this example, you can see I've extended two interfaces. So that is the unique part about interfaces. Now currently both of the interface has no methods. So let me create a method signature here. So let's call it public void print something, and let's implement the exact same method in drivable2 interface as well. So as soon as I click save button, as expected, the Ford and Toyota class is now broken, because drivable class is going to get these method in inheritance, and that means now Ford and Toyota developers are forced to implement new method, and they will hate you forever, as explained before. So let's not make them stressed. So we can instead provide a default implementation, and as soon as we add default, we have to provide the method implementation right here. So I'm going to call it printing. So if someone exercises this method, it will just print printing. Now let's copy the exact same method in drivable true. Now there is a reason why I'm copying the identical methods, because I would like to show you something. So as soon as I click save button, you can see that now drivable interface itself has an error. So what is that error is about? So what is happening here, that when compiler is trying to compile, it is seeing the two parent interface is trying to provide default implementation for an identical method. So compiler cannot make decision that which one is supposed to be the default implementation, and that's what this error is about. So this error is saying you must override one or the other method, otherwise I don't know how to use your default implementation. So whenever you extend interfaces, you must remember that the two parent class or more parent class that you are trying to extend from must not have the same method, otherwise you need to override them. So let me solve this problem by changing one of the method name to, let's say, print something 1, and you would see now all errors are gone. So it's working as expected. So now you guys understand how to use default method, how to extend interfaces, and what are the things you must not do when you implement interface and parent interfaces. Java 8 supports few different type of interfaces. So example, there is one type called functional interface that you can define by using a notation functional interface. And as soon as you apply this annotation, there are certain rules you have to follow. So one of the rule is that implementation cannot have any default method. It must be abstract. So we have to just have method signature. And another rule is that interface cannot have more than one method. So if I add another method, let's say do something 1, and you would also notice that now compiler is throwing error. So whenever you apply functional interface annotation, you must remember that you cannot have default method, and you only allowed to have one abstract method and one only, and then this interface will become functional interface. You must have a question that why do we have functional interfaces in existence? So since Java 8, Java has started supporting functional programming by using lambda expressions, and if you have interface which is considered as a functional interface, then you can convert that interface into lambda expression. So I will discuss that more into my upcoming tutorial, so I'm not gonna go into detail with lambda and how to use functional interfaces. So before we end today's tutorial, let me cover one simple concept which seems to confuse people quite a lot. So that concept is that you cannot create object of an interface, but you can use interface as a type for the object that is of a class which implements that interface. So what do I mean by that? So let's take an example that we have an object for array list. Now we know that array list implements list interface. So let me show you what do I mean by that. So if I create a new array list object, and let's give that object a name. So I'm just going to call it list string, because I would like to store all the strings into array list. Then we have to declare a type on the left hand side, that what kind of variable that is. Now we have two options here. We can either call the variable is of array list type, but we also know that the array list implements interface which is a list interface. So we are also allowed to use list as a type for the object of an array list. So that is the part which confuses people, because people think, oh, we may have created an object of a list, but actually we have created object of a class which is array list, which implemented a list object, and that's why we are allowed to use list as a type for that object. Now what is the advantage of these kind of behavior? So let's say I add some string objects here. So let's say hi, and let's add another object, hello. So what happened here, that we created a list type of object which is actually the array list object, and then we added some string objects here. Then after a while we realized that array list is not the right type of list that we wanted to use. We actually wanted to use linked list. So what we can do, we can just go ahead and simply change these to linked list, and our rest of the code doesn't have to change. Now the reason is because linked list also extends the list, and that's why all the method and everything else remains same. So this is the advantage of interface driven programming, and that's why instead of using abstract classes, I highly recommend everyone to use interfaces instead. And since Java 8 that now default method is supported in the interface, abstract class, which is considered as a partially implemented class, that has no reason to be used. So unless you already have an implementation in abstract class, please use interfaces instead, and then you can guarantee that your class will survive for longer. So that is all about interface, guys, and hope you enjoyed this tutorial. Please do not forget to subscribe if you would like to stay up to date with my upcoming tutorials. I would be making more videos as time permits. Until then, have a great time.